Time you're ready.
Leave it like that. For the last several years, I've been using YT for teaching. It's quite a handy tool. We teach a course on computational astrophysics. So this course is designed to introduce students to computational methods in astrophysics. So it's assuming very little, except that they have seen basic programming steps and may never actually have even written the full program themselves. So the course has to be adjusted to multiple levels. We have students who are comfortable programming in several languages to students who struggle with changing directories in Linux. So you have to have a range on how you address this. But our students are now, thankfully, have moved off of Java and are actually learning Python. So that does help. So it's helpful that this is YT is in Python, so they're at least familiar with the structure of the commands. And as we've been learning, there's quite a set of commands for visualizing and processing and dealing with simulation data. So the part that we use YT for is to analyze some ENSO data and body data. And it's just a simple illustration of the PM method, particle mesh method. So it's just using it's very restricted set of tools from YT and just handling the dark matter data. But it's actually quite useful for illustrating some basic principles, both on the methods and just the ideas of cosmological simulations. It is handy that there's online documentation, so I encourage the students to look at the documentation. Actually, they have to look at the documentation. When you teach a course like this, when the students are arbitrary levels, you have to show them step by step how to do things. So I'll give a little example of that. They have to go to the documentation. And in that sense, I tell them it's a real world. It's what the world is really like, and with all the good and bad aspects of that. So as you've been modifying YT and modifying the documentation, so have all of our exercises. Right, so so there are some practical aspects to deal with, right? Because the students will do a couple of workshops and then they get assessed. They actually have to use YT in a workshop and get assessed on it, and they have a little less than an hour to do that in. So everything has to be streamlined if you use it for teaching, right? So number one is you have to detail all the steps that they need to understand how the code works. Two, you have to do it yourself. Every year you have to do it yourself to make sure that all the bugs and quirks, right? I mean, you might not believe this, but sometimes things go wrong. And you have to have all the quirks worked out on the particular system that they're working with. It includes a Jupyter notebook, which is great. All students actually like to use the Jupyter notebook because that means that they can do all the exercises. They can also answer questions, even if you're not using YT. Well, you can use YT to process provide information, and then they can feed that in, as we've seen in these tutorial sessions. You can actually put text in as well, so that's quite handy as well. And we haven't done this yet, but I think we might do this now. You probably actually want to have it installed in its own container. The reason is some of the students have learned about pip, and they go pip crazy, and they've downloaded all kinds of Python software into their directories. And we have a TA here. There was a student who just couldn't get anywhere, and they did everything right, and they just couldn't get anywhere. It's because they had so many conflicting Python installations. So that's probably why you actually, if you're going to use it for teaching, you do want to put it in a container so that you make it more pip-proof. And then I'll just show an example. So this is the kind of structure. This is actually from our exercise, one of our exercises. So they'll be setting up an n-body code to actually do an n-body simulation using ENSO. And then they want to plot images of the density field and look at the distribution of the density fluctuations and do some beginning analysis on that. And then they continue to do that in another workshop. So you have to have And then we ask the students to write up a brief summary of what they found. And so typically this is the level you have to give it to them, right? If you don't do this, you're always going to find some students are just really totally lost. So you have to tell them how to start Python on the system, right? If you're doing it that way, or just use a Jupyter notebook, okay? And then all the steps for importing what they need. There is a very handy method that we use. It would be nice actually just to have that in YT. I don't know why you can't just have that as a one of the fields.
Over density.
Yeah.
Okay.
Yeah. And we show them how to load the data, and they're off on their way. So we give them examples. Okay, so these are examples of how to actually manipulate things, so they actually see how to work it. All right, so you can give them some basic steps without having to go to the manual. And then eventually we give them some steps where we tell them they have to look at the manual. Okay, and we give them just examples of how they can produce a plot step by step. Okay, and once they're able to do that, then they can start to do it with other things as well. So you just have to lead them by the hand, and then they can go on their way. And this is an example of one of the students' responses. All right, so this is using the Jupyter notebook. Okay, the commands. They've neatly answered some of the basic questions. You see them loading the data. They will typically do something like that and fill pages and pages and pages with rubbish, but that's okay, they're learning. Some nice plots. Now, this is the default in the instructions from YT, okay? And the default doesn't work very well. So they have to contend with that, and it forces them to understand how the simulations work to contend with this. And so most of them manage. So they get a little bit bigger, and then they realize, there we go. And they can actually produce the proper simulation. And there are some handy tools too that are actually quite useful for instructions. So the particle mesh method is a Fourier method, which means that it uses periodic boundary conditions. Well, YT actually allows you to demonstrate that. So you can shift the box and you can see specifically where it's periodically, and you can see the ghost cells you're not otherwise supposed to see. Right? So it really gives them a real idea of how these simulations are actually functioning. What are we seeing? It's a boundary set of cells to handle difference equations.
So the CIC routine in YT doesn't deposit into the ghost zones?
Yeah, of course. Yeah.
We have something. Okay, and then we let them track it down with different evolution steps, so they can see how the dark matter is evolving. And we relate that to the basic principles of dark matter evolution. And then later on and then this is a nice feature, is that we teach them how do you represent the density field when you have particles. So you have to have some smoothing algorithm, right? So Enzo's using CIC. We teach them about the other methods in CIC. And with YT, you can conveniently show that to them, right? So this is focus on the density field. I tell them, look at an 8x8 range, or so it's 8x8. He's got it, it's 8x8. And I say, now look at the particles. And you can do that. You can't see it very well, but there are dots there. It's not smudge. There are particles there. And you can try to match up the density field with the particles so they can actually understand why you can even get density in fields that don't have particles. But if there are not enough particles nearby, you get empty cells. So by analyzing having the capacity to analyze the really basic level of what's actually going on in the simulation, YT is actually quite a effective tool for teaching these base methods. And so that's all I want to tell you. Just to encourage thinking about using YT, but you do have to think about, as a student who doesn't know how to change a directory, right? How you can show them how to do it step by step.
Great, thank you, Avery.
Thank you.
Next time is added.
So the other version that works in browser.